Assalamu alaikum. The third lecture of DSP is about system and its properties. System is basically contains the process in which the signal is applied to the system and it will create an other signals at the output side. Like x of n is the input signal, and if we will apply it to the system, it will create an output signal y of n. So the system has the three types: serial system, parallel system, and the feedback system. In serial system, x of n is the input, and when we will apply this input to the system, and the systems are connected in series h1 and h2, it will create an output signal y of n at the output. Now the parallel system, here is the input signal x of n, and this input signal x of n is passes to the two systems h1 and h2, and these systems are connected in parallel, and the response of these two systems are basically add over the output terminal, and it will create an output signal y of n. Now the in feedback system, this is the input signal x of n, and it passes to the system h1 of n and creates an output signal. So from here, some of the output signal is fed back into the input, and the loops will start again and again. Now the properties of the system. So the first one is causal system. Causal system is basically depends upon the current or the previous value. Current value y of n is equals to x of n minus 2 of x of n minus 1. This is the current value, and this is the previous value. Previous value means the signal have some delayed with some variables with some constant values. And the non-causal system depends upon the advanced value, like y of n is equals to x of n plus 3. Here this is the advanced value, means the function adds up with some variable or some constant terms. The linear system, the name suggests it contains some straight line function, or the power should be 1. The system is said to be linear if it holds the additive or the homogeneous property. Here is the example of the causal system, like y of n is equals to x of n minus 2x n minus 1. So the system is said to be linear if it holds the additive property or the homogeneous property. First of all, we will check the function will be additive or not. So if we consider x1 of n, so if we put x1 of n in this system, then this equation will change to x1 of n minus 2x1 of n minus 1. So this is basically equals to y1 of n. Now we consider x2 of n. If x2 of n is put in this equation, then this equation will change to x2 of n minus 2x2 of n minus 1, that is equals to y2 of n. Now we let the dummy variable like z of n, then add both x1 of n and x2 of n, that is equals to z of n. Now the z of n is equals to z of n minus 2z of n minus 1. For example, this is the input variable, and if we pass it through the system, it will create an output signal, that is z of n minus 2z n minus 1. So z of n is equals to x1 of n plus x2 of n. Similarly, minus 2z of n minus 1 is equals to minus 2 x1 of n minus 1 plus x2 of n minus 1. So this is the 1 of n, y1 of n, and this is y2 of n. So it shows the system is additive. Now for homogeneity checking, this is the system x1, x of n and y of n. If we multiply the variable with input signal like alpha, and it shows also at the output signal. Z of n is the dummy variable. Similarly, it shows the output with alpha, like alpha x of n. So z of n, if we consider this is the input, and if we apply this input to the system, it will create an output, that is z of n minus 2z n minus 1. So z of n is equals to what? Alpha x of n. So if we put z of n here, then the equation becomes alpha x of n minus 2 alpha x of n minus 1. So now take it common alpha. Alpha is taken common by x of n minus 2 of x n minus 1. So basically this is equals to what? Y of n. Alpha y of n. So it shows the system is also contains the homogeneous property. So the linear system, it is the linear system. Now for non-linear system, the non-linear system contains the parabola, means it have the power of the system is greater than 1. So again check for the additivity and the homogeneity. Now the function is y of n is equals to x of n plus 5. So first consider x1 of n, then consider x2 of n. First put x1 of n in this equation, then it will change to this one, x1 of n plus 5, that is equals to y1 of n. Now consider x2 of n. x2 of n, when we will put x2 of n in this equation, it will change to x2 of n plus 5 is equals to y2 of n. Now add these two variables x1 of n and x2 of n. This is basically equals to what? y1 of n plus y2 of n. Now take the dummy variables and it will contain the addition of both these variables x1 of n plus x2 of n, and that is equals to what? x1 of n plus x2 of n is equals to z of n, and z of n plus 5. Now the z of n is equals to x1 of n plus 5, x2 of n plus 5, and plus 5 here is this. Now this is y1 of n plus y2 of n. So this shows that it doesn't hold the additive property. Now for homogeneity checking, this is the signal x of n, and this is the input signal, and this is the output signal after passing through the system, that is y of n. So multiply the beta with both input and the output. So z of n is the dummy variable. Z of n is equals to beta x of n. So z of n is equal, when we pass z of n through the system, it will create an output signal, that is z of n plus 5. So z of n is equals to what? Beta x of n. Then put this in this equation, beta x of n plus 5. So it also shows this does not contain the homogeneous property. Now the time invariant system. For time invariant system, here is basically the input signal x of n, and this is the output signal y of n. So it will contain the delayed function like x of n minus n naught, and similarly at the output end it will become y of n minus n naught. So this is basically the definition of the time invariant system. For example, this is the signal y of n is equals to x of n minus 2 of x n minus 1. So if we consider this is the dummy variable that contains x of n minus n naught, means it has some delayed function like z of n. If we will pass this input signal z of n to the system, it will create an output end with z of n minus 2z of n minus 1. So z of n is equals to x of n minus n naught. So we will put this z of n into this equation. Z of n is equal to x of n minus n naught. Similarly z of n minus n1. So it will become equals to minus 2 of x of n minus n naught minus 1. Now consider the output variable. Output variable is y of n. So y of n is goes to y of n minus n naught. So if we put n minus n naught over here, then the equation will changes to x of n minus n naught minus 2 of x of n minus n naught minus 1. So this is the time invariant system. The examples of daily life in time invariant system is projector, packet switching, and the fan. Now the time variant system. For time variant system, the function is y of n is equals to x of n ka square. So this is the dummy variable, and dummy variable is equals to x of n minus n naught. If we will pass x of n input variable to the system, it will create an output variable x of n square. So similarly, this is the dummy variable. If we pass this dummy variable to the system, it will contain the output variable g of n square. Now g of n square is basically what? X of n square minus n naught. Now consider the output variable. Output variable is y of n. Now it has some delayed function. Put n is equals to n minus n naught. So when we will put n is equals to n minus n naught, this equation will changes to x of n minus n naught whole square. When we will open the square, it will become like x of n square minus 2n into n naught plus n naught square. So this shows this function is a time variant function. The examples of the time variant function is internet system and the cooling system. Now the shifting property of the impulse function. So x of n is equals to summation of x of k into del of n minus k. This is called basically shifting property of the impulse function. Suppose we have an LTI system. This is the del n, and if we consider this is an input variable, if we pass this input to the system, it will create an output. So this is the unit impulse or delta function, not impulse response. This is the delta function, and at the output it will create the impulse response. So for impulse response, we will consider the impulse function as an input variable. Now the response to xn, if we pass this function to the system, it will convert into h of x of n, and similarly h of summation of x of k into del of n minus k. By linearity, it will becomes equals to summation of x of k into h of del of n minus k. But in time invariance, this x of k is the constant, and this will changes to the del function of n minus k. So this is an important equation, and basically this is equals to convolution function. Y of n is equals to x of n in multiplication of h of n. Now the state shifted version of the impulse response. This is the function y of n is equals to x of n minus 2 of x of n minus 1 plus 3 of x of n minus 2. So this is an original signal x of n. At 0, 1, 2 the value is 1, at 3, 4 and so on the value is 0. Similarly at minus 1, minus 2 and so on the value is 0. So if we put different values in this function, it will create some values like y. When we put n is equals to minus 2, the value it gives is equals to 0, like x of minus 2. At x of minus 2 the value is 0. Similarly at x of minus 3 the value is 0. Similarly x of minus 4 the value is 0. So as a whole, y of minus 2 is equals to 0. So y of minus 1 is equal to 0 and so on. Now the flip and the slide. The flip and slide is basically convolution. Convolution equation is y of n is equals to x of n into h of n, and it is also equals to x of n into h of k plus n. So x of n is equal to what? 1, 1, 1. H of minus k is 3, minus 2 and 1. This is what this value is lie at the origin, means 0. Like this is 0, this value is 1 at 0. Now here is this value and the positive values and the negative values. But if we shift this signal with some indexes, it will create the different signals like this. So y of 0 is equals to 1. When we put different values in this equation, it will create an output like y of 0 is equals to 1, y of 1 is equals to minus 1, y of 2 is equals to 2 and so on. So the applications of the convolutions are probability, statistics, computer vision, natural language processing, engineering, and differential equations. Now the correlation undergoes only the slide behavior. Convolution contains the flip and the slide, but the correlation contains the slide behavior, and the applications of the correlations in daily life are treadmill, shoe sizes, and the hair growth. Like if we run on the treadmill for more time, the more calories we burn, and if the man having large foot sizes, it will contain the shoe sizes large, but for small foot sizes the man needs the small shoe size. Similarly, hair growth. So this is all about today's lecture. Thanks for watching. Allah Hafiz.